folks, so before I go on to our next slide of calculations here, I want to deviate from my slides here. I forgot to make a slide for this. And I want to show a shortcut for how to use KSP based on our solids formula. Okay, so we're going to say shortcut for KSP calcs. All right, for KSP calculations. So if, for example, we have a solid that's MX, where M stands for the metal and X stands for the ligand, then we also recognize this is a 1-to-1 solid. So it will be in equilibrium with M, and I'll say, some charge plus N plus X minus N. So of course, we're now saying that, right, those charges are the same. Then my KSP is always going to be S squared, just S squared, okay? Because if you think about it, right, back in our previous calculations, we called one of these S, we call the other S. S times S gives me S squared. Okay. So now, what if I have a 1-to-2 solid? So something like this, 1-to-2, or I could even have 2-to-1, right? Either scenario. So in this case, I would have an M plus N, okay? And then now in my generic formula, I would have a 2x, and this would go minus n divided by 2. Don't worry about this, my generic formula right there. I'm just trying to note that if we had, like, maybe, let's say, a calcium 2 plus and a maybe an iodine 1 minus, right? This would fit that formula, okay? So now, if you think about it, my KSP is going to become 4s cubed. How did I get that? Well, we worked out this problem before, right? M was S. This was 2s, right? So then, so I'll write that comes from S times 2s all squared, okay? And of course, if I have M2x, where now I could write my formula something like, 2m, and then let's say that's plus n divided by 2, and now let's say that's x minus n, so basically just the other way around. My KSP is still going to be 4s cubed, which comes from the s times 2s all squared, okay? Beautiful. So now, what if I have an MX3, so a 1-to-3 solid? So once again, in my charge, right, I could write that as M plus N, and then of course this would be 3x minus N divided by 3, okay? And so now what's going to happen with this thing, so I'll write this off to the side, that's going to be S times 3s all cubed. So 3 to the third power is 27. And then now that's going to be s to the fourth power. And of course, if it was m3x1, it would be the same thing. And the last one that I'll work out, this m2, x3, which we actually just did that for the bismuth sulfide problem, right? A 2-to-3 solid or a 3-to-2 solid, right? So I could write that as 2m plus n, and generically that's going to go 3x minus 3n divided by 2. Once again, don't worry about this so much. What you want to worry about is the KSP expression, and so recall that went as 2s all squared times 3s all cubed, and that's what gave us the 108s to the fifth power. So these are our shortcuts for our solubility calculations. These are good to be able to quickly recall. Okay, now I'm going to record a part C for the last calculations.